Well, good afternoon and welcome to our Operation Excellence Seminar for Acme Corrugated. My name is Jeff Lukash, and I will be walking you through and introducing you to our program today. Today, we have a great opportunity for you to take an in-depth look at how we're using automation to enhance our operational efficiency and deliver superior results for our customers. Today, we're very fortunate to have our engineering manager, Ryan Stashko, with us. He is Acme's resident expert. He's going to guide us through our systems and processes. So for about 30 minutes or so, we're going to explore the innovative ways that we handle our work in process, or WIP, and transfer that throughout our facility. And we've got live footage that's going to showcase how these systems work in action. So what should you expect from our session today? Well, we're going to give you a comprehensive overview of those WIP transfer systems, the work in process systems. You're going to see some real-time demonstrations of our iFast monitoring system. You're going to get some detailed insight into how our high rack storage solutions work, as well as an exclusive look at our conveyor and transfer car operations that we move our materials on. So once Ryan concludes his portion, I'm going to do about a 15-minute Q&A where I will take questions from all of you who've attended today, share those with Ryan, and he can answer your questions. So at this point, I'm very pleased to introduce Ryan Stashko, who's going to start us off with an overview of our automation systems and the critical role that they play. Ryan, the floor is yours.
All right. Thank you, Jeff, for that introduction. Let me just pull up screen here. All right. Should be visible. So first off, thank you, Jeff, for the excellent introduction. And thank you to everybody who's joined the webinar this afternoon. My name is Ryan Stashko. I'm the engineering manager here at Acme Corrugated Box. And I'm excited to be able to give you guys a behind-the-scenes look at our very advanced WIP transfer system, one of many different automated systems that we have here at Acme that really sets us apart from the rest. I've been working with Acme since 2018, so next month I'll be celebrating 7 years with the company. And in that time, I've seen tremendous growth, exponentially, really, at Acme, and how we innovate and install new technologies and harness the power of automation to advance our systems and processes. So for me, it's been an excellent journey up to this point. And in 2020, we've had the unique ability to undertake a large expansion project, which involved expanding the building, installing a new corrugator, and installing and upgrading a lot of the WIP systems that we'll be seeing today. So in my role, I've had that unique perspective and given a interesting privilege to be able to be close to a lot of these projects and to be able to see the growth and how these systems have helped launch Acme to the forefront of our industry and continue on that path from here and beyond. As we know, technology is constantly evolving, it's constantly advancing, and Acme prides ourselves on harnessing that power and utilizing technology to our advantage to meet our ultimate goals. So I'll be taking you guys on a virtual tour of our WIP transfer system, and the system you're about to see is a testament to Acme's commitment to staying at the forefront of innovation and continuing to focus on how we can be excellent in everything that we do and how we can provide the best quality to our clients. So with that, we'll go ahead and get started. So first, let's define what WIP is. I think Jeff may have touched on it, but it stands for work in process. In our business, it's the stacks of corrugated board that are produced on the corrugator, but not yet made into finished boxes on the converting side. The WIP transfer process is the system for how we move WIP from the corrugator to storage and then eventually to the converting side of the operation. It's a critical process for our business, probably arguably one of the most critical. And for us, it needs to be safe, it needs to be efficient, and it needs to make sense. So today, like Jeff mentioned, I'll be taking you through step by step how we transfer our WIP from the corrugator to our automated high rack storage system, and then ultimately to the converting side of the plant. And truly, I'll be touching mainly on how this sets us apart from the rest and how we've deviated away from the traditional way of doing things and why it makes us more efficient, more safe, and ultimately provides a better use for how we get to our end goal. So with that, we'll go to the first part of the process. So this whole system begins at the corrugator stacker. So what you're seeing here is what we call whip units. It's the corrugated sheets that are made into these blocks or units of board. We have 3 stackers on our corrugator, each one capable of running a different order, so we can run things simultaneously. Specifically, what you're looking at here is stacker 1. So as the machine stacks the board into a single unit, the elevator will drop down and then transfer the unit onto the outbound whip lane. So for this, on what this process looks like, there's no barcodes, no tagging whatsoever. All of the data about what's being produced off the corrugator is seamlessly transferred via software from the scheduling system to the software that controls the conveyor to make sure that everything runs seamlessly and smoothly and that the system knows everything about each unit being produced. The only human interaction that you see at this point is the operators who check the board for quality and make sure it matches customer specification. What you see here is this automated bar that can push each unit over to the side and make room for another stack that can then be built into what we call super blocks. This maximizes the amount of space that we can use in the racking system, and it also cuts down on the amount of congestion that happens on the conveyor lines and the transfer cars to make sure that things continue running smoothly and efficiently. So from there, our whip unit will then continue on down the line on its journey to the high rack storage system, or we also have the ability to run our units directly out to the converting lines. We can bypass the rack if there's what we call hot orders or orders that need to run immediately so that we don't waste time having to go through this process. We can go straight to the converting side. But most of the time, all of our whip gets transferred down this line as it's prepared to go into the high rack system. At this point, it's probably good to highlight the way that we used to operate and the way that most box plants operate today, which, as you can see here, we don't have pallets, we don't have forklifts, we don't have any banding. None of that is required in this process because of the gentle transfer between conveyors. In the past, and how other box plants operate today, they use a system of forklifts, management supervisors, palletizers, banding machines, to make sure that all the units between the corrugator and converting are structurally sound and safe before they get to their next step of the process. None of that is required here, and it cuts down on waste, makes for a much safer environment, and ultimately increases our efficiency throughout the line. So what you're seeing here is the next step in the process before it gets to the high rack. So even though we don't require pallets, forklifts, or banding, there is still some prep work needed, which again is all done autonomously. Because of the highly advanced automation, everything runs off of sensors and photo eyes. So even though a lot less material is required, there still needs to be a lot of precision involved. So what you can see here are these inline squaring stations that each come in and square up each unit before it enters the rack to ensure that everything is nice and tight so that it keeps product flowing and doesn't interrupt the racking system or cause issues. So despite not having the intricate system that we had before with a lot of manual and human intervention, there's still some prep work needed, but all of it is handled through the software system, and it keeps everything moving down the line without interruption so that things flow flawlessly and seamlessly. So from here, our whip unit enters the next step right before we get into the high rack. So what you're seeing here is our first of many automated transfer cars. This is our high rack transfer car. It's basically a conveyor on wheels that moves the whip into the rack and also handles outbound whip coming from the rack 24/7, 365 with no human operator necessary. As you can see here, this unit is being sent into one of 2 different aisles that we can send whip in to our racking system. And then once it drops that unit off, it'll then go to the next part, which is picking up the next unit that's ready to come out of the rack. So as this unit gets picked up, it'll be received by the transfer car and then sent down the outbound side where it's eventually sent to converting. Again, all of this is controlled over the cloud with the different software integrations that are all talking to each other at all times, so that converting knows when a job is needed on their machine, it'll automatically talk to the rack to be able to get products sent out this transfer car and down the whip lanes. Similarly, the racking system knows exactly what's coming in at all times, and knows precisely how to set it and where to put it within the rack to ensure that there's space and it's placed in an area where it can be recalled easily. So let's dive a little into the high rack system, which really today is the centerpiece of the plan. Standing at 60 feet tall and having 4 aisles of rack space, it's our temporary storage hub for our work in process before it gets to the converting side of the operation. The high rack is controlled or contains 2 automated stacker cranes. Again, 2 pieces of equipment that don't require a human operator. Each one of these cranes run back and forth down these aisleways all day long without the need for a human operator. And each one of these cranes handles putting WIP into the rack as well as taking WIP out of the rack and bringing it out to converting. Each crane is equipped with these forklift style arms that actually reach out and grab the unit as it's bringing it into the crane. This ensures that there's no damage to any of the sheets within the unit, making them all usable and allowing them all to be converted into boxes. Previously, and the way that things typically do operate in this process with forklifts and banding, it often has damage that's caused to either the bottom few sheets and even some on the top few sheets that are typically always destined for the waste bin. But in this process, because everything is designed to transfer gently with no damage to the unit itself, it makes it so that virtually every piece of board in every unit that we store is usable in the operation, which completely cuts down on unnecessary waste. From here, again, because of the software integration that we have set up, the crane knows exactly where to be at all times. So for this specific point, this unit that enters the loading station needs to be picked up by the rack or by the crane. So the crane comes, knows when to pick it up, and picks it up to send it out into the rack. So from here, it'll pick up the unit and then send it on its way based on what it knows about the unit from size, specifications, and when it's needed to be pulled out. It will then store it in a location that makes the most sense from an efficiency standpoint. Again, all of this is controlled automatically with hardly a second thought to anybody who's out on the plant floor. So just another few points on the high rack, just going back here a second. So the racking system itself is only the second of its kind installed in a corrugated plant in the United States. From a storage perspective, it allows us to store up to 9 million square feet of corrugated board. That's in contrast to how we typically were to run this process, which is taking it off the machine with forklifts, and all of our WIP used to be stored on the plant floor. As you can probably imagine, that's a messy process and it's not very safe, and it also can be very inefficient. However, this system allows us to maximize our storage, giving us 3 times the amount of space that we were allowed to store on the floor before. We were capped around 3 million square feet. This gives us 9 million square feet, which increases capacity, but it also allows us to run or shut the corrugator down for required maintenance while not starving the converting side and allowing that part of the operation to run without any interruption. Additionally, this whole system is managed by 1 person per shift. So before, like I mentioned, it was a team of forklift drivers, supervisors, and operators that were responsible for making sure each step of this process flowed seamlessly. But as you can imagine, with any sort of human process, there's always delays and inefficiencies that come up. But with this system, because it is fully automated and tied into all of our software integrations, it is handled by 1 person who oversees everything and simply makes sure that everything's running smoothly and addresses any faults or issues as they come up. So from here, our WIP is pulled out of the rack when it's called to from the converting side. So when it's ready to be converted into finished boxes, it'll then be pulled from the rack and sent out our outbound WIP lanes. From here, it'll enter the next step of the process, which is the final step, sending the units to the converting machine to be made and converted and eventually sent to our clients as finished boxes. So again, there's another system of transfer cars on the converting side that will come and pick up each unit. Again, all of this is tied into the software, so it knows exactly where to be at any given time, just like the cranes. So when a unit is ready to be picked up, the transfer car will arrive and then pick up the unit and send it on its way to whichever converting machine that it's destined for. Again, no pallets, no tags, no humans whatsoever. So because of all of the flow of data between the different software integrations and knowing where all of this stuff needs to go and when, all of this happens seamlessly with hardly any delay. So on the converting side, the operators are not starved for work. They're not constantly having to look and see what can be sent to them next. They are constantly fed with whatever is in their lineup at all times without really needing to give a second thought to it. So this process in general is as if you were calling for an Uber or your Uber driver shows up before you're even finished requesting the ride. Something that would be kind of creepy in real life, but for us in the corrugated plant works pretty well. So that begs the question of how does all of this run so seamlessly with such little human intervention? And the answer is IFAS. So IFAS is an acronym for Intelligent Factory Automation System. Essentially, it is the brains of this entire operation. So IFAS is directly integrated to our plant scheduling software and the conveyor systems, high rack, and corrugator side as well, so that it knows and it orchestrates this whole process from start to finish, knowing what's being received from the corrugator, where it's going throughout the process, whether it's straight to converting or over to the rack, and finally, which machine it needs to go to and when. In addition to orchestrating this whole process, these IFAS screens are installed throughout the plant, allowing operators to see a visible real-time view of the entire operation from these screens, knowing exactly where units are at any given time. It's also cloud-based, so our scheduling team can see this upstairs at all times as well. So if there's a job that they know is needed on a certain machine, they can simply look at this screen, identify it, and know exactly where it is and when it will be entering whichever stage of the process it needs. This is showing an example of what that looks like in real time. You can see the boxes as they were being conveyed are shown on the screen here. Let's take a look at that again. So as the transfer cars move on the screen, that's where they're moving in real time. And same thing here, you'll see this green box start moving to the next conveyor that's physically represented in real time here on the infeed line. So it allows us to view WIP, track WIP through the entire process, and it displays it on all of our IFAS stations to ensure that we don't lose track of any units. Going back to how we used to do things with manual tags and barcodes and storing all of our units on the floor made it difficult to make sure that we knew exactly where everything was at any given point. This system solves that problem by ensuring every single order number can be looked up in this system and have a specific point on these screens where we can see where it is, whether it's in the rack, on a conveyor, or on a converting machine in feed. It gives us a whole lot of flexibility and again, orchestrates this entire process from start to finish. Without having IFAS, none of this would be possible. And it takes a process that would take a team of several different individuals and several different processes all the way down to one single point where it only requires one person to operate the entire system. So with that, that's our overview of the process. Like I said, I hope that this is something that was informational to everybody here. I know we'll have some questions coming in the chat. So I just wanted to make sure that we were able to highlight probably one of the most advanced pieces of our process in the plant as of today. And it's only one part of how we truly innovate here at Acme and harness the power of automation. We have several different other processes that are always being looked at on how we can automate and make better. But I hope that this was informative to the group today, and I'm happy to answer any questions as I turn it over to Jeff.
Well, thank you so much, Ryan, for that exceptional presentation. I mean, ultimately what you've seen today represents the cornerstone of our commitment at Acme to innovation and efficiency. Our automation systems not only enhance our production capabilities, but they ensure consistent quality and reliability for all of you, our customers. So at this point, I'm going to open the floor up for questions. We're going to use the next 10 to 15 minutes to answer them. There is a chat function available. I see people are already putting questions in there, and I'm going to kind of just run through the list. So our first question comes from Donna. Brian, her question is, once whip units are delivered to the converting machine, is there a way to return it to the rack if necessary?
Yes, that's a great question, one that was brought up when we were first designing this system because things happen, mistakes happen, issues come up. So when there is a job that is sent to the converting line that for whatever reason needs to be sent back to the rack, there is a way that is designed into this system and into the programming where it allows us that ability to send it back to the rack if necessary. At this point in the game, now that we're all very used to running the system and being familiar and comfortable with it, it's very rare to have that as something that comes up. But if it does and when it does, we have the ability to get around it.
That's awesome. So our next question, Ryan, comes from Taylor. She's wondering, how does the automated whip transfer process improve plant safety?
It's another good one. So all of this from where we were to where we are today is truly in the name of safety. Like I said before, this whole process involved forklifts, storing whip on the floor, a whole lot of obstructions that if you're just someone walking through the plant could come in contact with, and it could be a potential safety hazard. Taking all of that away and having all of this integrated into a system that is both blocked off from operators entering the high rack, for example, or having conveyors that we can walk over if necessary, or have stop points to walk over conveyor safely, eliminates all of that and really cuts down on the amount of dangerous traffic throughout the plant. Also, our transfer cars that you saw that are on the plant floor are all equipped with safety sensors on either side. So if someone were to be walking through or near a transfer car while it's running, those sensors will sense a person or objects, and as it gets closer, will slow down and stop until the obstruction is out of the way.
That's fantastic. We have a couple more questions that came in while you were speaking, Ryan. Our next one is from Beth. How does automation impact our labor needs at the plant, and has it impacted or changed any roles?
So that's another good one for how we changed things recently. Like I said, we used to use a whole team of forklift drivers on each shift to do this, and now that is no longer necessary. But thankfully, when we did make this transition, all of those roles that were filled with forklift drivers previously were all reassigned within Acme at different parts of the operation. So it allowed these people to branch out and become either machine operators, clamp truck drivers, or transition their role over to shipping where they can continue driving a forklift. So while it does cut down on the labor needs, it allows us to optimize the existing labor that we had, putting them in areas that were weak previously, but can now be strengthened by having automation take over some of the more busy or mundane processes.
Oh, that's great. Let's see. We just had another one come in. It says, have you ever had an incident when the T-car stops working during the loading or unloading of whip? And if not, how would you address if that happened?
So I believe that question is related to the high rack transfer car, if I'm not mistaken.
Correct.
So
Yep.
yeah, so obviously that's a big failure point for us, and it's why we take seriously our preventative maintenance on things like that. So we built as much redundancy into this system as possible, but we have had issues with the high rack transfer car, and unfortunately, there's not much around it other than knowing how to get it back up and running as quickly as possible. So our team has been trained both in the field and before all of this was installed on how we can address those issues. And when those issues have come up, they're typically resolved quick enough to where it doesn't impact the operation.
That's great. We have another question, wondering how the systems have helped us with controllable waste.
Yes. So, like I said, most of our waste that we had to put up with, or that was kind of just chalked up to, necessary evil or necessary waste from before, is almost eliminated. So I don't know the numbers off the top of my head, but I know from where we were before to where we are today with the high rack and the conveyor system, our controllable waste numbers have improved drastically. And it's actually one of our main metrics here at Acme for assessing performance. And that controllable waste number has been within range since we've started this system up, and it's only improved over time. So it goes to show that we can really control all of our waste through changing this process like we have.
That's excellent. Well, I mean, they were just 5 exceptional questions. I was just giving it a minute here before we wrap up in case there's any others, but I hope that those 5 people that took the time to ask questions, which we appreciated, got the answers that they were hoping for. We did get another question just come in. How does the racking system impact the need for warehousing or our ability to switch the lineup for an urgent order?
So that's another. So for warehousing, obviously, because this isn't finished product, it's work in process, so it's always moving in and out. Typically, what we have in the storage rack is typically 1 to 2 days worth of WIP, I would say, maybe even less. So it's constantly moving. And in the case that we need to get a hot job or a quick order out to the machines, it's essentially a push of a button. So our scheduling team can look at the lineups that we have set already and what is already in progress and moving on the lines, switch some things up on the computer, send that out to the system, and then everything takes over from there and moves things around as needed.
That's great. Thank you. Thank you very much. So the next question from Eric. Has the racking system allowed Acme to reduce trim on or around your corrugator?
So for trim waste, I believe that's
Yes.
probably related to. Yeah. So again, I don't know numbers off the top of my head or where we're at on a reduction side, but I do know that it has significantly impacted our reduction for trim waste and allowed us to reduce the amount of waste that we have throughout each unit that we produce.
Yep. Frank had a follow-up question to the T-cars, commenting that it appears that the T-car are the only motorized component on the high rack system. Is that correct?
So another great question, one that was brought up again during the design phase of this, and it's all about eliminating the potential for failure. So the high rack, yes, is motorized. The only other part of the racking system that is also motorized are those 2 stacker cranes. Everything else on the rack side is all static and does not move. So where the product is placed in the rack are just literally what it says, racking. There's no moving parts inside the rack. It's all picked and received onto these racks that don't move whatsoever. So that's a huge plus when it comes to mitigating failures. We had a few other design concepts that were considered during this time, one of which involved the racking system also being conveyors inside. We realized that that could potentially pose an issue down the line with managing failures and keeping up with maintenance, but what we have today really significantly reduces that risk.
That's outstanding. Thank you. Thank you again, Ryan, for that very detailed answer. Well, at this point, we've certainly had a lot of questions, and we appreciate everyone taking the time to ask such thoughtful questions as well. So as no more have come in, I'm going to conclude our session today by just thanking everyone for making time out of their day to attend. We greatly appreciate your interest in our organization. We do want you to know that you do have additional questions. Please feel free to email them to us. We will happily do that. And we want to tell everyone to have a great afternoon. But before we close out, I would like to extend an offer to anybody that's attended today to come out to Acme for a plant tour. You're always welcome. It's amazing to be able to see videos, but I would say, and I know Ryan would agree, that a video truly doesn't do 100% justice to seeing it live and in person. So please know that there's an open invitation at any time. Reach out to us here at the organization, and we'd be happy to set that up for you. So with that, I wish everyone a great day. And on behalf of myself and Ryan, I'd like to thank everyone for attending. Have a great afternoon.
Thank you.